Well, cool. So what I'm going to do is show you how to solve this quadratic by using our AC method, or when our absolute value of a is greater than 1. So it's going to be very similar to the process when a was equal to 1, but there's going to be a couple variations. So first thing, we always want to look to see, can we factor any common terms in this quadratic? And the answer is no, they don't have any common terms. And since we're solving, we're going to want to set our output value equal to 0. Now make sure we understand that's the absolute value of a. When greater than 1, we have to apply this method. So even though this is a -2, we just know that the graph is now going to have end behavior that's going to focus down. However, the absolute value of -2 is 2, which is greater than 1. So therefore, we're going to have to apply this method. So I'm going to use the AC method, which is going to be very similar to our diamond method that we used before. However, when a was equal to 1, we just had c. But now we have a is greater than 1. We're going to do a times c, and then b on the bottom. We're still going to multiply up top and then add on the bottom. So now I need to do, what is a times c? Well, the a is -2 and c is 13. So -2 times 13 is -26, and our b is -11. So now we need to figure out what are our two values that are going to multiply to give us -26 and add to give us -11. Now remember, these two values are not going to be your p and q like they were when we just had a c up there. This is going to be a little bit different, which I'll show you. So let's go and write out the factors of -26. So we know that one of the factors has to be negative. So it's either -26 or -1. But out of all those factors, which are the only two that are going to give us -11? Well, obviously, it's going to be these two factors when we have 13 being negative. So I'm going to say my two values are -13 times 2. And let's just double check this. -13 times 2 gives us -26. -13 times 2 adds up to give us -11. All right. So now what we're going to do, rather than saying these are our two factors, because they're not our two factors, what we have to do is apply an extra step. So what I'm going to do is now I'm going to rewrite my equation. But now, rather than writing -26, I'm going to rewrite it by using these factors. So I'm going to rewrite -11 by saying -13x plus, let's write it the other way, plus 2x minus 13x plus 13. All right, so what you can see is all I did was I rewrote -11x as 2x minus 13x. And that is correct. That has not changed the value of my equation. All I simply did is rewrote it. And the reason why I'm doing that is because now what I'm going to do is I'm going to group my first two terms and my last two terms. And now I'm going to factor each one of these individually, which we call factor by grouping. I'm grouping the first two terms and the last two terms. So to factor these out by grouping, I'm going to factor out the GCF of each form. When I factor out the GCF, I'm going to write in red. So I look at -2x squared plus 2x, and I say, what do these two have in common? And we always like to factor out our negative. We don't really like having that -x. So we're going to factor out the negative. So let me factor out a -2x. And therefore, that's going to leave me with, a -2x will leave me with an x minus 1. Then here, I'm going to want to factor out that -13. So let's factor out a -13. And when I factor out a -13, I'm left with an x minus 1. So therefore, now I have it in a factored form, but it's not completely factored, because now I can see that my whole expression still shares an x minus 1. So I'm going to factor out an x minus 1. And what is left over is a -2x minus 13. Now I have rewritten my original equation as a product of two factors. And you can double check to make sure that you didn't change the value by multiplying this out and making sure that you get back this original equation. However, now we have our equation that's written as a product. So now we can apply the zero product property to solve for our values of x. So we can say x minus 1 equals 0 and -2x minus 13 equals 0. Now I just solve for x by using my inverse operations. So therefore, I have x equals 1 and x equals a -13/2. And those are going to be my x-intercepts, my solutions, my roots, my zeros. However, our question is really going to be answered. But there is what we call our AC method for factoring a quadratic, or solving by factoring quadratic when our absolute value of a is greater than 1. Thanks. Almost.